Regarding the equation that we have seen here, just you can number it. So at t equals to 0, that means any t, if you just pick suppose equation 1, if t equals to 0 as well as your x equals to 0, t and x both are zeros, the phase angle of the particle is plus minus phi. Why? You just put t's here. Okay, so what it t's and x as well as both the values will be 0, so you will be left that the phase angle of the particle, you will be left with only a sign within bracket plus minus phi. So that means this is your phase angle. Okay, I'm explaining once again. Consider just equation 1. Okay, so here what we are trying, what we are writing, both t and x to be 0. Okay, so if your both t and x are 0, so if we put these values here, so both these terms will get vanish, so you will be left with only plus minus phi. So the phase angle of the particle is plus minus phi. Okay, because you will be left with only a sign plus minus phi. Okay, I am writing it here. We had in our equation y equals to a sine omega t minus kx plus minus phi. So we'll be left with only a sine within bracket plus minus phi. Why? As tx equals to 0 and t equals to 0. Okay, very easy calculation. So this is called as the epoch of the progressive wave at the origin. Okay. So this particular thing is called as the epoch of the progressive wave at the origin. Okay. So we have discussed that what is the initial phase will be and what is called as the epoch. Okay. Now let us move ahead to the next form of the progressive wave. Okay. So we can assume right now we will start the particle velocity and the acceleration in a progressive wave, student. In the class we have discussed that what is a particle velocity, how does it move. So in this class we will learn that what is a particle what is the acceleration of the particle of the progressive wave. Okay, the particle velocity and acceleration in a progressive wave we will study in this class. Okay, so as usually just we can assume the displacement of a particle in a progressive wave as y equals to a sine within bracket omega t minus kx plus minus phi. Let us assume the displacement of a particle in a progressive wave. Okay, so if this is the displacement, just think of the mathematical calculation. So what will be the velocity? Velocity means just you have to differentiate it for one time. So your velocity will be, that is v dy by dt. Just you have to differentiate for one time. So what will be the value? Just use mathematical concept. So it will be omega a cos within bracket omega t minus kx plus minus phi. Just we are writing it in the form of differentiation of the first equation. Just differentiate it for the one time. How is it coming? We had in the previous one a sign within bracket this one. So you will, after differentiating it, all the constants will come out. That means v equals to omega a cos, and you will be left with the full term that was in the previous equation. Clear? So let us just write the previous equation. V naught within bracket cos within bracket omega t minus kx plus minus phi. Okay, just we are just putting the value of this as V naught. Clear? So the maximum velocity of the particle B plus minus omega A, or just plus minus V naught. Plus minus omega A we have assumed to be as V naught. So we are writing what we are writing, that the maximum velocity of the particle B plus minus omega A, that means plus minus V naught. Okay, omega A means V naught. Okay. So this particular V naught, the constant that we are putting in place of this omega A, is called as the velocity amplitude. Alright. So this V naught is called as the velocity amplitude of the particle in a progressive wave. Okay. So from this particular equation, let us write this equation as equation number 1. Okay. So from this equation, we can write sine within bracket this full thing, omega t minus kx plus minus phi equal to y by a. We had this equation, just we are bringing this a in the denominator part, so you will be left with, in the LHS we are putting the sign and the term inside the bracket, and in the RHS we will have only y by a. Clear? So in the next step we can express it as cos this full term okay equals to 1 by root 1 minus y square by a square. I will explain this term, don't worry. Okay, let me explain this first. Okay, what we are doing, we had in the previous equation, what we had, sine within bracket omega t minus kx plus minus phi, which is equal to y by a. Okay, so in the next equation we are just putting it as cos within bracket omega t minus kx plus minus phi. Okay, so if you want to express this sine term into the cos term, so you will get the value as root 1 minus y square by a square. Why? Because in maths, I hope you have learned the formula sine square x plus cos square x equal to 1. So using this formula, you can able to find the value of cos theta, or this cos within bracket omega t minus kx plus minus phi. Is it clear? So I think this part is okay to all. Just the mathematical calculation.